So when I go back to the problem again, we took care of part A. I'm going to kind of replace that histogram with this probability distribution. Now I can answer my questions a little bit more easily because I'm looking for probabilities. And it says the first one here, find the probability that given any 3-minute interval in the study, that there is at least 2 and less than 6 customers in line. And so what that translates into is that X is between 2 and 6. It includes 2, because at least 2 means 2 or more. But less than 6 means, okay, I have to be under 6. I could also have put this and said, well, I'm looking for the number of intervals that had 2, 3, 4, or 5 people in line. I mean, there's different ways to reword it as well. But then all I really had to do for this at this point is, just take this, these probabilities in this region right here, going from 2 to 5, and add them together. And that's what you're seeing here. And so I ended up with 31 divided by 60, which is about 0.516 repeating. Find the probability that any of these 3-minute intervals, there's between 7 and 9 customers. So again, and I'm including both of those. That's why it says inclusive. So I'm looking at these 3 pieces of data right here. So I'm going to add those 3 probabilities together. And I get 13 out of 60, which equals 0.216 repeating. And then find the probability that given any 3-minute interval in the study that there is at most 4 customers. Now, at most 4 customers means 4 or less. So I want the probability of being, at 4 or less. So I'm going to go from 4 down to 0 and add these probabilities together. And I get 0.4 repeating 6s. So those are your probabilities for each one of these studies, which, kind of gives you an idea, how many people tend to be in line most often, in these express lanes at this time on a Saturday. Might have to decide, how many, they need more cashiers or whatever the case might be. So.